Okay, good day, everyone. I want us to discuss the concept of the practicals with relation to your semiconductor devices. Now, uh, the first practical or the first section of the practical, it will be based on your rectifiers. Now, if you refer back to your practical guide, you will see that you've got practical 2 or number practical that talks about your rectifier circuit. Now, the one that I have presented in front of you is a half wave rectifier, which consists of one diode and a resistor connected in that circuit. Now you will see that your circuit from the beginning, that is where you will have your transformer, so which means that is your transformer configuration. Now, if you go to the lab, you will see that in the lab, you will have your transformer configuration, but on the lab, with your transformer configuration, the only part that you only see the secondary side, which means you only see that side there, which is your secondary side of the transformer. But the transformer there, it is constructed in such a way that you got, or that transformer is the center tap transformer. Now, with that center tap transformer, you will see that you will have positive there, you will have ground, which is your G and D, and also you will have another positive there. Now, it simply means that if you are looking at this as a center tap transformer, from here, or when you measure from here to here, you're going to get half of this entire signal. From here to here, also, you're going to have half of this entire signal. But now we talk about center tap when we get to the side of center tap. Now, allow me to open a Word document whereby it consists of example, more or less example of your circuit. Now, if you look at this example of your practical circuit, on your study guide, you will see that here, that is where now you are looking at practical 2, which is the rectifier circuit. Now, if you go down with this, or if I scroll down, that is the theory part of the summary theory part of a rectifier circuit, and there you'll see that you're given the input, of which your input signal is an AC input signal. Now, with this input AC input signal, which means that is the signal, if you look closely enough, which means that is your AC input signal, which means that is the signal which is on the secondary side of your transformer. This is your secondary side of the transformer. When you look at this, it becomes your secondary side of the transformer. Then, if I go back, then you will see that when you read all this information, now it tells you exactly what is a second rectifier circuit in terms of full bridge rectifier, half wave rectifier, center tap uh, rectifier. Now, if you scroll down again, then you have the material needed for your practicals. Now, with the material needed for your practicals, I have got examples of the material needed for your practical. You need resistors, you need 112.6 volts AC center tap transformer with a fuse line cord. Now, the center tap that I was talking about, the one which is being given there, this is the center tap that I was talking about. You will see that that is your center tap transformer. Now, with this center tap transformer, it simply means that when I measure the voltage from here to there, I'm going to get that 12.6 volt. That is when I measure. But now, if I measure from here to here, which means I'm going to get half of this, which means it's going to be 6.3 there. From here to there, also is going to be 6.3 volts. That is when you measure the voltage, how you find it in your laboratory. Now, then from there, that is your 12.6 volts. That is your AC. Remember, don't forget, this is your AC voltage. Now, if I go back to that guide of ours so that it can give us clarification. Then you have got your transformer that you find in the lab. Then you have got a 4 diode 1N4001, Your 1N4001 now. You will see that on that sketch that I gave you, it says 1N4007. They fall under the same category. These they fall under the same category. This one here, which is your D1N4007, D1N4001. They fall under the same category. If you look at the data sheet, you'll see that their specification in terms of the data sheet, or their characteristics in terms of the data sheet, they are the same. Now, going back to my circuit, then you will see that it says you need one capacitor, which is 100 microfarad capacitor. Now, with this 100 microfarad capacitor, that is your electrolytic capacitor. That is your electrolytic capacitor. Now, these components, I have them with me, whereby now I'm going to show you how do they look like, because that is very important. The theoretical analysis of this, it's easy to understand, but now we need to transfer that theory knowledge into the practical aspect. Now, this is the nature of your diode. This is the nature of your diode. Now, you'll see that I've got 4 diodes as mentioned there. These are my 4 diodes. Those are my 4 diodes. Now, with these 4 diodes, you will see that they've got a silver lining. You will see that this diode has got a silver lining. I don't know if it's going to be visible for you, but the silver lining of the diode, when you look closely enough, you will see that your silver lining is there. Your silver lining is there. Now, with the silver lining, simply means that is the negative side of your diode. Then the other part of it, that is the positive side of your diode, which means this diode, if I put it on a circuit, that is how that diode it is going to look like. Now, these are your diode. Then from there, you have got a capacitor. Now with the capacitor, we are using an electrolytic capacitor, 100 microfarad. Now this is the capacitor that they're talking about. But now, this is just a typical example of the capacitor. Now, with the typical example of the capacitor, you see that this capacitor will consist of 2 pins. Now, we have got the longer pin, which is this side, and you have got the shorter pin, which is this side. Now, this simply means that the shorter pin is the negative side of the capacitor. The longer pin, it is the positive side of your capacitor. Then if you turn with the body of the capacitor, now you'll see that the negative side of the capacitor will have this marking here. Now, this marking simply means that with this pin, that is the negative side. But now this side without the marking, then you will see that that is the positive side. But when you put it down in terms of viewing, you will see that the longer leg, it is your positive side, and the negative side, it is your shorter leg. Now, on this circuit of our mine, I haven't included the capacitor, because when I do my experiment, first I need to find what is the output voltage, or what is my output readings without the capacitor, my output readings with the capacitor. So I will include the capacitor when we do the readings with the capacitor. Then another component which is important again into your circuit, you said you're given 2 resistors. Now this is how the resistor looks like. This is how a resistor looks like. But now with the resistor, it doesn't have polarity. With the resistor, it doesn't have polarity. If you connect it on the circuit like this, it will work. If you connect it on the circuit like this, it will still work, which means it will be able to conduct current in any position how you put it on your circuit. Now again, we've got another capacitor, but this one has got a smaller body, which means the smaller the value, the smaller the body, the bigger the value, the bigger the body. Now, with this one, the same thing applies. With this one, the same thing applies. You will see that that is the positive side. The longer leg is the positive side, and the shorter leg is the negative side. The longer leg is the positive side. This is the positive side, which is the longer leg. The shorter leg, which is this side, that is the negative side. That is your capacitor. But now, when we do a half wave rectifier, now I will have to go back. Let me go back to my description of the circuit. Then if I scroll down, the description of the circuit, if I scroll down, now that is the procedure at which this is the circuit that I'm looking at in terms of determining what will be your output. What will be your output? Now, you will see that with these, you have got CT, which means that is a center tap. Like I said, in the lab, you have got a center tap transformer. But when you connect with this center tap, you will see that now you are going to connect in this way. Now you're going to connect in this way. It simply means that when I look at my circuit, I'm going to use this piece of uh, chopped cardboard so that you can see. Now, this is what you find in the lab. So, which means this is what you find at the lab. Now, at the lab, what you have is you will have one socket there, another socket there, and then another socket there. But you'll see that this one or the colors will be different. Which one? This one, it is going to be your GND. This one, it is going to be something like red, and this one also something like red. But now the connection there, which means your connection will be between this point and that point there. That is when you are looking at it at the lab, but which means you're not going to even consider the middle one. You only consider these when you are using a center tape, because I'm not using a center tape, which means I must look at this in this way, and also I must look at this in that way there, which means when I measure from here to here, when I measure from here to here, I must be able to measure 12.6 volts. Then therefore, when I'm done with this, which means I will have a probe which is going into my circuit, and also I will have a probe which is going into my circuit. Now with this, then I will go and say, now I need to connect my circuit. When I connect my circuit, then I will say, this is the diode that I need to use, because on a half wave rectifier, you only use one diode. Now with this one diode, then I will make life easier for myself. Then I'll say, let me try to draw a circuit on this sketch board so that when I insert, I just insert according to how it's supposed to be. Now, if I say at this point, that is where I'm going to punch a hole. Simply means that when I punch a hole there, when I punch a hole there, I'm going to insert these pins that I see there. But when I insert these pins, then the positive side of my diode must be connected there. The positive side of my diode must be connected there. Then I will say, if I connect the positive side there, then I will have this as my diode indicating the negative side, and I also punch a hole there. It simply means that now I'm going to take my diode, bend my diode according to the distance that I see there, and then put my diode there. It simply means that these end pins, then you have to put it, because your current to conduct, it must be able to travel within these legs of the component, because that is a good conductor of electricity. Then from there, then I will say, now I need to connect the next component. Remember this, we are trying to build this circuit here practically, because this is the theoretical analysis of this. Then practically, then I will say, now I need to include the resistor. Which resistor? This resistor here, because I am measuring within 2 points of the resistor. One probe goes there, then another probe goes there, which means that is the positive side and that is the negative side. That is the measuring points. Then I will say, within these or on the same hole there, let me insert one leg of my resistor there, of which if I insert one leg of the resistor in there, so that it's going to combine with these one here. One leg is going to combine with that one there, and then the other leg, I will have to connect it within this margin here. I will have to connect it within that margin there. Now, these lines that you see here, it's either you are using a wire or you're using any type of material that will conduct electricity. Any type of material that will conduct electricity. These lines that you see here, any type of material that is conducting electricity. Now, then I will say, let me punch a hole there. Now, then I punch a hole there. I just have to make sure that electricity it is flowing. I cannot use the marker and think that now with this marker here, if I draw my circuit here with this marker, then I'm going to get the output or I'm going to measure current flowing. No, we need to make sure that we have got wires that can conduct current. I don't know if I've got any wires somewhere here. Uh, just give me a moment to check if I've got any wires. Yeah, there you go. This is the wire. More or less an example of the wire, which means then I will go and say a wire must be connected from here. This is a normal wire that can conduct electricity. I hope you can be able to see. This is the normal wire that can conduct electricity. You must make sure that it is made out of material that conducts electricity. Now, then you go and say from that input, which is at the lab, which is the secondary side of your transformer. Remember, this is the secondary side of your transformer. Then I'm going to say, let me connect wire from here up there. If I connect wire from here up to there, it simply means that now I am conducting current, which means this wire, I need it as an example of that wire there. Then also here, I connect wire from here up to there. I hope you'll be able to see. I connect wire from here up to there. Also, it simply means that I am conducting from here up to there. Now, your current must be able to flow. If your current is not flowing, you're not going to get any readings. Once I get this circuit of mine in this manner, once I get this circuit of mine in this manner, remember I'm doing this at home so that when I go to the lab, then it becomes easier for me to just go take my circuit, go there, take the measurement according to what they are looking for. If we go to the measurement side, there, if you go to the measurement side, it says V secondary. I need to measure the secondary voltage, or I need to give what is the secondary voltage that I see. Your secondary voltage, where do you get it? You will see that that is the voltage that you're measuring from this point up to that point there. That is your secondary voltage from this point up to that point there. That is your secondary voltage. But in this case, you will see that on your oscilloscope, you have got two channels that you need to connect, of which one channel will give you the secondary voltage and one channel will give you what will be on the output, of which what is there on the output, it is going to be your half-wave rectifier. If you don't know what is a half-wave rectifier, refer back to the notes during your theory period whereby a half-wave rectifier was explained. Now, you will see that here also there is a point of ground. That point, that is your point of ground. In your circuit, what is your point of ground? In your circuit, what is your point of ground? Then you will see that the point of ground, it is connected. Sorry, let me go back. Your point of ground, that is the ground point to your circuit. That is the ground point to your circuit, which means that the signal must be able to travel in this manner here. The signal must be able to travel in this manner there. Where are you measuring? I am measuring between where your diode and where the leg of the diode and the leg of the resistor are combining or are joining each other. That is the positive side of your clip when you connect it to the oscilloscope. Here, that is the negative side, which is this side. That is the negative side. That is where you put the negative clip to your circuit. Then you'll be able to see what will be your output. But now, if I were to demonstrate just for a demonstration of the negative side and positive side. Now, you will see that with your circuit, this is what you're going to find as the secondary side of your on your oscilloscope. This is what you're going to find on the secondary side of your oscilloscope. But now, what you're going to find on the output, Remember, this is the input, secondary. Then I need to have an output. An output which is measured between this point and that point. Then you will see that as a half-wave rectifier, during the positive cycle, the diode switches on, as it has already been explained in theory class, which means you're going to have a cycle like this. But this cycle, you will see that the peak that you see here and the peak that you see there, it will be a little bit different because it will have a drop of what? A voltage drop that you measure across here, which is 0.7 volts. Then during the negative cycle, because the negative cycle, which means you are looking at this thing going this direction here, diode blocks, then you will see that your graph will look like this. Then this will continue happening up until you disconnect your circuit. This will keep on happening up until you disconnect your circuit, which means on the secondary side, this. Sorry, there. On the secondary side, sorry, on the V out, that is the voltage that you are going to get, the one that I just demonstrated there. Then you plot your graph there, or you call your technician, you said, I have plotted this graph, come and see, this is my input from the oscilloscope, this is my output from the oscilloscope. Then you can be evaluated in terms of you giving out what is the graph. Then it says, if you move forward with this experiment of yours, if you move forward with this experiment of yours, you see that there it says, what is the measured value of the secondary side? What is the measured value of the or V out peak, computed V out peak measured? Computed, it's calculated. Measured, it is the one that you measure according to your measured according to your oscilloscope. Remember, you have got an oscilloscope, that is where you are doing the measurement. Now, again, you have got what we call with capacitor. With a capacitor. Now, with capacitor simply means that now on your circuit, you need to go and include a capacitor. Sorry, you need to go and include a capacitor. You have done the measurement with a capacitor, without a capacitor. So which means in this case, then you go and check what voltage are they looking for, or what is it that they are looking for? Are they looking for this with or without capacitor? Now, if you go back to your circuit, then you say, now I need to include the capacitor. It says the capacitor must be included in parallel with your resistor. The capacitor must be included in parallel with your resistor. So which means if I include the capacitor in parallel with my resistor, then I will go and take the capacitor. Remember, the capacitor has got polarity. Remember, the capacitor has got polarity, as we have already discussed. Then you will see that the positive side of the capacitor will be connected there. The positive side of the capacitor will be connected there, and the negative side of the capacitor will be connected there. Now, once you connect the capacitor, remember the longer leg means, if I put it in this way, the longer leg means positive, the shorter leg means negative. Then I'm going to take my capacitor, bend it a bit. I must not disconnect its internal connection. Then, as I have bent it, you'll see that if I put it down like this, I hope you will be able to see. If I put it down like this, you will see that there, the longer leg is connected where the positive is, the shorter leg is connected where the negative is. Which means, it simply means that I can even go into that hole that I've connected these two there. This hole that I've created that I said I will connect these two. Then I go and include my capacitor there, if it can fit there. Or I just expand it so that there can be a bit of a space that exists in between there. Then I said, let me make sure that current it is conducting within the capacitor, the diode, and the resistor. Current is conducting within the negative side of your circuit. Now, can you see how this connection is done? Can you see how this connection is done? Then from there, now you have designed your circuit in terms of the cardboard. Now, this You don't present these in a cardboard. You don't present. What you present, it's only your circuit. This component, that component, that component, with wires that needs to be connected into your supply, with wires that needs to be connected into your supply, and also with space whereby now you can also even include the wires there. Here you can also connect the wires there, so that when you want to do the measurement, then you just go and connect within your oscilloscope, which means if I take this wire is going there, sorry, this wire is going there. If I connect wires there, which means the end of this is going to the oscilloscope. If I connect wire there, the end of this also, it is going to your oscilloscope. Now you have designed yourself a half wave rectifier. Ali, can you pause it?